Hello everyone. In this video, let's talk about how we reduce rational numbers, or in other words, how we simplify fractions. On the screen, I have the rule that we use to do this. It says if a over b is a rational number and c is any number other than 0, then a times c divided by b times c, that is equal to just a divided by b. So in other words, as long as my numerator and my denominator have a common factor, that common factor will simplify to 1 and we can reduce our fraction. So let's just start with a really simple example just to explain that a little bit more. So let's look at the fraction, let's do just 4 over 6. Okay? Now 4 over 6, these are both even numbers, meaning they're both multiples of 2. So what that means is if I wanted to, I could rewrite them as 4 is the same as 2 times 2. And 6, this is the same as 3 times 2. So now looking between my numerator and my denominator, I can see that they have one of these factors in common. They both have a 2. And if I wanted to illustrate this even more, I could go one step further. And one of the rules we have with fractions is when it's multiplication, I can actually separate these. So we would end up with 2 over 3 for one fraction. And our second fraction would just be 2 over 2. And this was our common factor. And I know that 2 over 2, this is equivalent to 1. So this is how we simplify. So because that common factor divides and simplifies to 1, 4 over 6 is going to simplify to 2 over 3. Okay, but maybe we need to try out a little bit more of a complicated example. These are pretty small numbers and we can see that they both have a 2 and we can divide that out. And that works for a lot of them. But what if we have a larger number? Something like, I'm going to do a new page. Let's say we want to reduce and let's do the fraction 130 over 455. Now, one way that we could approach this is I could take a look at those two numbers and I could reduce it a little bit. Right away, I see that they both have a 5 in there, and then we might have to keep going. But another way is we can use something called the prime factorization. The prime factorization is when we take a number and we split it up into all multiplication of just prime numbers. We did that a little bit in our first example. 4, if I rewrite this as a multiplication of just primes, is 2 times 2. 6, written as prime numbers, is 3 times 2. And once they're written in just primes, we can easily see what the common factors are. So let's take both of these numbers and rewrite them in their prime factorizations. So first, let's start with 130. One way that makes this pretty easy is I'm going to make a little tree diagram to break down my number. So first, 130, this is the same as 13 times 10. Okay, not the only way I had to start, but that was the most obvious to me. 13, this is already a prime number, so I can stop here. But 10 is not a prime number, so I need to break this down even more. And 10 is the same as 2 times 5. 2 times 5, those are both prime numbers. So these three numbers multiplied together, so 2 times 5 times 13, this will result in 130. All right, let's do the same thing for 455. Now this is a little bit of a bigger number, So we might have a little bit more work to do. Okay, the first one that comes to mind is I know that 455 is a multiple of 5. So this is the same as 5 times 91. 5 is a prime number. 91 is not a prime number. I happen to know that 91 is the same as 7 times 13. 7 and 13 are both prime numbers, so 5 times 7 times 13, that is equivalent to 455. So if I go back to my original fraction, these two numbers, I can rewrite them in their prime factorization. So the numerator is 2 times 5 times 13. And the denominator is 5 times 7 times 13. And now written like this, it's really easy to see what my common factors are. Between the numerator and the denominator, I can see that we have a 5 in common. So 5 divided by 5 will simplify to 1. And we also have a 13 in common. So those will also simplify. And then what we're left with is our reduced fraction. So 2 over 7 is our simplified answer. So this method, there's a little bit of work to it, but it does give us a process. It gives us an algorithm that is going to work every single time we want to reduce fractions. Especially helpful when we're dealing with bigger fractions like the one we had in our example. Thanks.